Right, can we start now? Right, Bismillahirrahmanirrahim. Chapter number 10, multiple linear regression. So last class, we have looked into simple linear regression. In simple linear regression, we know that the objective is to find relationship between dependent variable and independent variable. Right, so how to find the relationship? First, we perform or construct equation, regression equation, and then find the standard error of estimate, and then coefficient of determination. And then we have testing the slope, right? Coefficient beta 1. And last, we have learned yesterday, which is ANOVA table, right? So that is for simple linear regression where we have one dependent variable and one independent variable. So for multiple linear regression, the learning objective, at the end of this lesson, you should be able to use least square method to estimate multiple linear model. So it's the same method from a simple linear regression, right, which is a least square method. So next, you should be able to carry out tests to determine if the model obtained is an adequate fit to the data. Right, carry out the test for inference on regression parameter. Right, so that is the objective. So for multiple linear regression, is actually an extension for simple linear regression, where in this topic, we have one dependent variable and more than one independent variable. Means that two or more lah. But in this, for constructing or calculating regression equation, we will focus, we will limit our independent variable to two dependent variable, right? So that is for calculating regression equation lah, right? So this is the linear regression equation, right? Y equal to beta naught plus beta 1 x1 plus beta 2 x2 until beta k xk, right? So and plus with the error term lah. Okay, so the dependent variable is related to k independent variable or regression lah, regression. So this is the objective of multiple linear regression. So the multiple linear regression model can provide a rich variety of functional relationship by allowing some of the input variable xi to the function. Right, so as in simple linear regression, the parameter beta naught, beta 1 until beta k are estimated using method of least square. Remember, to establish the equation, we use a least square method. Right, so same goes to multiple linear regression. We're going to use a least square method to establish a multiple linear regression equation. So however, in multiple linear regression, it will be very tedious to find this value by hand. So thus, we will use computer to handle computation lah most of the time. But in our topic, right, so we will try to calculate the regression equation for one dependent variable and two independent variable, right? So we will limit until 2 lah, y equal to beta naught plus beta 1 x1 plus beta 2 x2. Right. So, and then we will use ANOVA table to test the significance of regression as we learned yesterday, right? So to test the model fitness, the validity of the regression model, we will use ANOVA table. Right. T-test is used to test the inference of individual regression coefficient, right? Okay. So this is a repeated thing, right? So let's say we have data y, dependent variable x1, x2 until xk. The regression equation will be like this lah, until beta k xk, right? So y will represent the dependent variable. Beta naught is intercept. Beta 1 until beta n will be the regression coefficient of the individual independent variable. X1 until xn is your independent variable. So our interest in multiple linear regression is the regression coefficient is 95% confidence interval and the corresponding p-value. Right. So as in your assignment, you are required to do two approach. First by using critical region, another one is by p-value approach. Right. So this is the likelihood function of multiple linear regression, right? So this is a likelihood of the error term. So from the error term, we will use to establish our regression equation. So to get beta naught, beta 1 until beta k, we need to differentiate with respect to beta I and equate to 0. Right. So this is the first thought to find the likelihood, the beta 1, beta 2 until beta n lah. Right. So this is basically the formula that we're going to use. Right. So this formula is not given in your statistical table. You need to remember how to construct this equation. And we will use a simultaneous equation to solve for beta naught, beta 1, and beta 2, right? So the first equation will be n multiplied with beta naught plus beta 1 summation of x1 plus beta 2 summation of x2 equate to summation of y. So this is the first equation. This is the second equation and third equation. All together, we need to have 9 summary, numerical summary, right? So which is summation of x1, summation of x2, summation of x1 square, summation of x2 square, summation of x1, x2, summation of x1 y, summation of x2 y. And last is the observation lah. Altogether, we should have 9, I think. And then last is summation of y. And another one is altogether should be 9. 1, 2, 3, 4, 5, 6, 7, 8. So by using this equation, right? So we're going to solve by simultaneously to get beta naught, beta 1, and beta 2, right? So I'm looking for another formula. So there is another way to find beta naught, beta 1, and beta 2 by using the formula. So beta 1 will be summation of x2 square multiplied with summation of x1 y minus summation of x1 x2 multiplied with summation of x2 y divide by summation of x1 square, summation of x2 square minus x1, x2, and then you square. So this is another way to find beta naught, beta 1. So beta 2 will be the same. Instead of x1, x2 square, so we are using x1 square. So multiply with summation of x2y minus summation of x1, x2, summation of x1y. And divide by the same denominator, summation of x1 square, x2 square minus summation of x1, x2, and then you square. Right. So this is another way. So beta naught can get from the concept of simple linear regression, y bar minus beta 1 x bar 1 minus beta 2 x bar 2. And this formula is not given You need to practice to remember it. So you can choose either the first method or second method. This is the first method or second method. I think the first method should be very easy. This one not given. Yes. So you need to do a lot of practice to understand and remember the formula. Okay, done. So based on these two methods, I think the first method should be very easy, right? So just plug it into the formula, into the calculator, and you will get the result. Right, so let's look at example number 1. So this is very long data. We have 25 data. So, but later I will show you how to use calculator with small data, right? So now, based on example number 1, we want to find estimate regression equation. So we want to estimate regression equation. So this is the summary that we have. Basically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 summary measure. So by using the formula, the first equation, the first method, so we're going to use n beta naught plus summation of x1 beta 1 plus summation of x2 beta 2 equal to summation of y. Another, this is the first formula. Another one is beta summation of x1 beta naught plus summation of x2 x1 square beta 1 plus summation of x1 x2 beta 2 equal to summation of x1 y. And the last one is summation of x2 beta naught plus summation of x1 x2 beta 1 plus summation of x2 square beta 2 summation of x2 y. So by the value provided in the example, we just plug in into the formula. So n is equal to 25 beta naught plus 206, which is summation of x1 beta 1 plus 829 beta 2 equal to 725.82. So this is the first equation. Second equation is summation of x1 is 206 beta naught plus summation of x1 square 2396 beta 1 77177 beta 2. So this is 8008.47. This is the second equation. Yeah. Oh, 8294. Okay. Terlepas satu. Beta 2. Right. So this one is summation of x2, right? So it should be 8294 beta naught plus 77177 beta 1 plus, this is a summation of x2 square 3531848 beta 2. This is a x2y should be 274816.71. This is third equation. Okay. So just plug in into the form calculator. So calculator, click on menu. Are you following me? Menu, and you need to find A, which is equation and function. Right? So I think in this one you already know kan, dah buat dalam calculus, right? Dia learn in calculus. Calculus or metric algebra. So this is just choose simultaneous equation. We have unknown, 3 variable unknown. So you just plug in the value 25, 206, 8294 point, sorry, no point. And last is 725.82. Right, this is 206, 2396, 77, oops, 177. You need to input carefully, right? And this is 8294, 77177, 353184. The last is 274816.71. Right. So input the value carefully, and you can double check the value. Right. Check whether the value input correctly. So X will be your beta naught, right? You take 2 or 4. Maybe depend on question lah. Sometimes it says 2 or 4, right? 2.26. Okay, maybe I salah, ada benda yang salah kan? Check balik lah. This is 25. This one. Okay, so 3531848. So, right, 2.2. So you should get y equal to 2.26 plus 2.74 x1 plus 0.012 x2. So this is your estimated regression equation for multiple linear regression. Okay. So I think the first method should be okay. If you want to try second method also can, but I think this one should be the easiest one. Don't forget to sign in your attendance. Yeah. Yes. Manually. Yeah. You use calculator and then get the value. Yeah? I don't know. No need. Waste of time. You only have 3 hours, right? So don't worry. I will mark your paper later. Okay, done. Any questions so far? Question? No question? Right. Let's continue to the next slide. So multiple linear regression. the ANOVA, so if you want to test the significance of regression, we will use ANOVA table, right? If you still remember from yesterday, right? Yesterday, if you want to test the significance of regression by using ANOVA table, so beta null hypothesis, beta 1 equal to 0. Alternative hypothesis, beta 1 is not equal to 0, right? Still remember yesterday? So this is for simple linear regression, right? So in multiple linear regression, we have many independent variables. So it should be, it can be tested by using null hypothesis, beta 1 equal to beta 2 equal to beta 3. It depends on how many variables you have. Let's say you have only 2. So null hypothesis, beta 1 equal to beta 2 equal to 0. And alternative hypothesis, at least 1 beta I not equal to 0. Right. So this is the standard hypothesis statement for multiple linear regression to test the significance of regression model. And for test statistic, we will use F value from ANOVA table, and where we get MSR is SSR divided by K. K means that the number of independent variable, right? And MSE is sum of square error divided by degree of freedom. So in this case, same as yesterday. Yesterday we got n minus 2, right? Why? Because n minus k plus 1. So k, we only have one variable. So it should be minus 2, right? So this one, n minus k plus 1. So k, let's say we have two variables, 2 plus 1, n equal to 25, 25 minus 3, right? So F rejection criteria are same as yesterday, right? So we need to draw critical region and find the critical value. So your critical value is alpha, degree of freedom 1, and degree of freedom 2. Where degree of freedom number 1 is equal to k, degree of freedom number 2 is equal to n minus k plus 1, right? So all others value such as r square follows the same formula as chapter number 9, right? So this is a multiple linear regression ANOVA table, same design, right? So first we have sum of square, degree of freedom, mean square, and F value. So the first row is regression, the second row is error, and the last is total. Okay? It's the same table, but the difference is the degree of freedom, right? For yesterday, the degree of freedom for regression is 1 because the value of the number of independent variable only 1. In this case, we have 2 or more, right? So K is the independent number of independent variable, and this is a degree of freedom for error and degree of freedom for total, right? So to test the significance of independent variable, right? It's the same concept as in a simple linear regression, right? So we need to test by using T statistic, right? So T statistic is beta hat I minus beta naught divided by, so this is a beta I naught, huh? So this is the regression equation. So it should be 0, always 0. So divide by standard error of beta I. So where the standard error of beta I is equal to standard deviation of estimate divided by SSX, and we take a square root lah. So this is the confidence interval for regression coefficient, same as previous, right? But the difference is the degree of freedom. We take degree of freedom from one ANOVA table n minus k plus 1. Right? Okay. And this is some term that you need to remember. Standard error of estimate. So we take from the ANOVA table, which is square root of MSE. R square is equal to sum of square regression divided by sum of square total, or 1 minus sum of square error divided by sum of square total, right? So in multiple linear regression, we have two R square. The first R square is our original one. Another one we have adjusted R square. So there are no difference between R square and adjusted R square in terms of interpretation, right? In terms of interpretation, there are no difference. Means that, let's say we have R square equal to 93%. It means that the total variation can be explained is 93%. So same goes to R square adjusted. But in R square, for multiple linear regression, where we input, when we include more or variable, independent variable, definitely R square will be increased, right? But R square adjusted will not increase when you will not increase drastically when you include many independent variable, right? So see here, R square adjusted does not increase drastically compared to R square each time the new predictor variable is added into the model, right? So this is the formula to calculate R square adjusted. So 1 minus R square multiplied with n minus 1 divided by n minus k plus 1, right? So based on example number 1, try to complete ANOVA table. This is example number 2, right? So let number this value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. So how to find number 1 regression equation. So why? So we're looking at the first table, right? So y equal to 2.264 plus 2.74 x1 plus 0.0125 x2. So this is a regression equation. And to find number 2, t is equal to beta I, the coefficient value, divided by standard error of the coefficient. So 2.264 divided by 1.060, right? So this one should be equal to 30.49. For number 3, it's the same concept. 2.74427 divided by 0.09. So 0.09 is the standard error of the coefficient, right? This is the coefficient value. So this one should be equal to, this is 2.14. This is 30.49. And the last one should be 6.25. Right. Okay. Boleh? Any questions so far? So you can apply the first concept, example number 1, in your assignment. Remember your assignment due date is 26 July. You can refer your group member dalam Ulearn juga. Alright, number 5. So how to find number 5? Standard error of estimate. Standard error of the estimate is equal to sum of square error divided by the degree of freedom error. Right? Which is also equal to square root of MSE. So this one should be sum of square error is 115.2 divided by degree of freedom for error. Right. So how to know how many variable do we have? How many observation we have? This is n minus 1. This is n minus k. How many k we have? 1, 2. 2 plus 1. This is k, which is equal to 2. This is based on example number 1. So example number 1, we have n equal to 25, right? So remember? N equal to 25. Oops. So this one, number 9, should be 24. Number 8 should be equal to 22, right? So this one divided by 22 square root, or we can get how much? 2.288. So this is the standard error of estimate. Okay. And then number 6, which is R square. R square is equal to sum of square regression divided by sum of square total, or 1 minus sum of square error divided by sum of square total. So we use the first formula. 5990.4 divided by 6105.9. This one should be equal to 98.11%. So it means that there are 98.11% of the total variation in Y, which is strength, can be explained by X1 and X2, right? And to find MSE, number 10, right? So this one should be 115.2 divided by 22. So this one should be equal to 5.236. Right. And the last one, which is 11. 11 is the F value. F is equal to MSR divided by MSE. So this one should be 2995.4 divided by 5.236. So this one should be 572.04. Right. This is how you complete the table. So next week we only have 2 class, right? Then submit, kan? study week or study days. Okay. Any questions so far? Question belakang? No question? Okay. Right. Let's look at example number 3. So this one will be in your final. No lah. So a set of experimental runs were made to determine a way of predicting cooking time, which is Y, and various level of oven width, X1, and temperature, X2, right? So we want to estimate the multiple linear regression equation. So to estimate multiple linear regression equation, so we need to use n beta naught plus summation of x1 beta 1 plus summation of x2 beta 2 equal to y. And x1 beta naught plus x1 square beta 1 plus x1 x2 beta 2. This is x1 y. And last is summation of x2 beta naught plus x1 x2 beta 1 and x2 square beta 2 x2 y. So basically we need to have 9 measures. So using your calculator, you need to input at least 3 times to get the value lah. Or if you have a faster technique, then you can tell me. So use y plus bx. So we input the value, the first value x1 and y. So the first one, 1.32. Carefully, right? So x1 and y, so apa value yang kita boleh dapat? So number 2, we can get summation of x1 equal to 60.1, summation of x1 square 448.461, and then we have summation of y equal to 489.16, summation of y square 34, summation of y square 34,883.8932, and last we need to have summation of x1 y equal to 3881.4465. So how many observation measure kita dapat? 1, 2, 3, 4, 5. Another 4. Right. So we go to option and click on 4 data. So just now we input x1. So now we're going to input x2 1.15. Betul? This is 115. And then collect the data. So now we want to have summation of x2 equal to 156.46. Summation of x2 square is 3991.120. And summation of x1, x2, x2y. x2y is 11750.0263. Right. Next, we need to have another value, which is summation of x1, x2, right? So we need to input another data, click option and 4. So this is x2, right? Remember? And then we need to put x1 here. So 1.32. And the last one is x1, x2, which is this one. Summation of x1, x2 equal to 1284.0365. So altogether 9 measures. Okay. So all of you have the same calculator, right? Okay, good. Never? So buy this calculator lah, ya. All right, so next we just input the value into the equation. So n is equal to 10, right? So 10 beta naught plus summation of x1 60.1 beta 1. x2 is, where is x2? 156.46 x2 489.16. This is the first equation. Second equation is x1 is 60.1 beta naught. X1 square is 448.461 beta 1. X1, X2 is 1284.0365. X1Y is 3881.4465. This is the second equation. Right. Last equation, summation of x2 is 156.46 beta naught. X1, X2 is 1284.0365 beta 1. X2 square 3991.1208 beta. This is beta 2. Equal to x2y 11750.0263. Third equation. Right. So use calculator to solve the equation. Click on menu. Find equation, which is A. Right. And use number 1, simultaneous equation, and select 3 values. So have you done? Dah? What is your beta naught? 5.5? Is it? Salah key in ke? 0.5, right? Tengok sekarang kat mana salah? This is 60.1 ke 60.07? This is 448. Yeah, 448.461. Okay. Is it 0.50, right? Okay, so this is y equal to 0.50 69 lah, right? Plus 2.7220x1 plus 2.0484x3. So this is the regression equation. Okay, so in final assignment, even though you can use Excel to compare the result, but you need to compute by calculator lah. So this is x2, right? Okay. Right. Let's look at example number 4. So example number 4, based on example number 3, using a computer, complete this table. Can you calculate the value of question mark? So let's say this is 1, 2, 3, 4, 5, 6. So this is not 6. This is 6. So only 6 value. For the first one, how to get T? T is equal to beta I estimate divided by standard error of beta I. Right. So in this one, 2.706 divided by 0.194. So this is equal to 13.9484. But before that, regression equation. So this is y equal to 0.568 plus 2.706 x1 and 2.05 x2. So what is the value for temperature? 2.051 divided by 0.046. 44.535. Okay. And standard error of the estimate. So number 3, square root of MSE, which is equal to, our MSE is 0.401. So this one should be equal to 99.9%. So there are 99.9% of the total variation in Y can be explained by width and temperature. Our Y is cooking time. And R square is equal to SSE divided by SST. So there, sorry, this is 1 minus SSE divided by SST, or SSR divided by SST. So this one should be this is 99. Number 3 is 0.6332. So this is a 99% lah. Salah tengok. Okay. So how to find degree of freedom for regression? So K is equal to 2. And total, we have N equal to 10 minus 1, 9. Right? 2 plus 7 equal to 9 lah. That's all. Sudah Tera? Done? Done? Sudah? All right. Based on example number 5, example number 5, based on example number 4, test whether regression explained in the model obtained in part A is significant at 0.01 level of significance. So we need to test for the regression equation and regression model. Beta 1 equal to beta 2 equal to 0. At least 1 beta I is not equal to 0, where I equal to 1 and 2, right? And alpha equal to 0 0.01. Test statistic. We look at F value. Our F is 113,000, right? So by logic, like if you look at this one, if the F value more than 10, right? It should be significant already. So we reject null hypothesis. The CCs are 13,647.872 critical region. So this is by critical region method. So our rejection area is on the right hand side. So this is F alpha DF1, DF2. So F 0.01. Degree of freedom number 1 is 2. Degree of freedom number 2 is 7. So this one should be how much? Table 8. Right. 2 and 7. 0 0.0. 0 0.05. Wait, this is based on 0 0.01. Right. 2 and 7, right? 2 and 7. Okay. So this is degree of freedom number 1, 2. Degree of freedom number 2 is 7. And we look at the alpha value, which is 0 0.01. So this is the F critical value, 9.55. Boleh faham? Right? You know how to read the table? So this is 9 point. Right. So our decision, reject null hypothesis since F calculated more than F alpha DF1, DF2. So our conclusion, so you ganti Y with dependent variable name. So dependent variable is cooking time, right? Cooking time is linearly related to either X1 is level of oven and X2 temperature or both. Done? Right. So try to do example number 6 by yourself. Do it now. You want 5-minute rest? Okay.
但是有可以找到八十块的，家里可以找。哎呦，我就是不行。什么钱？没有，大不了那个有什么的。啊，看哪里的情况就不了。这个没有吗？会有一点这种结束了那个，其实就我家还收尾。哪个不推动？按照说，我直接我在那就你们在那哪就没到。哎呀，都行了。反正会先塞。我拉了。老。把想让你啥？那直接我自己的上这种来，对对。道理，就是道理。不是打就死了，人搞非常死的。我有这个讲。Salam，那这样子。走。这个。哎呀，哎呀，这边有没有放一个？我不知道别的。
Right. Can we continue? Yeah. Right. So what is the equation for this one? Y equal to 78 point. Apa 84.215 minus x1 minus 49 x2. Right, good. Okay, done. So now let's look at example number 7. So in this example, we have 4 independent variables. So this is a 4 independent variable. We have y equal to birth weight. X1 is mother pre-pregnancy weight. X2 is gestational age. X3 is mother smoking status, where 1 is smoking, 0 is non-smoking. And X4 is cigarette smoke per day by father. And this is the regression equation. And this is a ANOVA table, R value, R square, adjusted R square. So by using the p-value approach, right, identify which variable that should be dropped from the model at 5% significant level. So this one we're going to use t value by coefficient table. So we have 4 independent variable. So null hypothesis for number 1, beta 1 equal to 0. Alternative hypothesis, beta 1 is not equal to 0. This is the first statement. Second statement, beta 2 equal to 0. Beta 2 is not equal to 0. Number 3, beta 3 equal to 0. Beta 3 is not equal to 0. Beta 4 equal to 0 and beta 4 not equal to 0. So alpha equal to 0.05, right? And test statistic. So we are using p-value, right? So this is p-value for the first one is 0.031. This is p-value for number 2 is less than 0.001, because this is not actually 0. The probability for an event should not equal to 0. This is basically very small number. So number 3 is 0.13, so 0.013. And number 4, 0.443. So our decision, reject, if p-value less than alpha, which is 0.05, null hypothesis is rejected. So based on the decision rule, so this is accept null hypothesis because the p-value is very small, less than 0.05. And this one is also accept null hypothesis, accept null hypothesis, and this is reject null hypothesis. So we can conclude that x1, x2, and x3 is a significant linear relationship with y. Except x2, x4. X4, put in proper word lah. So they are significant linear relationship between y and x1, x2, x3. Yeah.
Value then 0.05.
Huh?
I mean, 0.06 less than 0.5. So H equals would be
Oh, sorry. Dia terbalik lah. Yes. I put a confused. This is a reject. Okay. So there is, when we reject null hypothesis, we conclude that there is a significant relationship between dependent variable and independent variable. There are no linear relationship between y and x4. Okay. So which variable should be dropped from the model? X4, right? Okay. So second question is, interpret the coefficient of for variable mother smoking status. So mother smoking status beta 2, beta 3, right? X3 is mother smoking status. X3, this is B, is mother smoking status. So beta 3 is equal to negative 0.347. What does it mean? It means that when mother smoking status equal to 1, which is smoking, so we know that 1 is smoking and 0 is non-smoking lah. Right? So when Okay. So same interpretation as in simple linear regression. Numbers for next question, C. So we want to estimate the equation for smoking and non-smoking mother, right? So this is C, when X3 equal to 1, which is smoker, right? So the equation is Y equal to negative 3.685 plus 0.20x1 plus 0.144x2 plus 0.003x4, right? When x3 equal to 0, so y should be equal to negative 3.338 plus 0.20x1 plus 0.144x2 and 0.003x4. Basically, we just substitute the value into the equation. Okay. Any question? So the last question will be, how do you explain the difference between R square and adjusted R square? So for number 4, R square is equal to 0.6442, right? It means that there are 64.2% of the total variation in birth weight of newborn babies can be explained by X1, X2, X3, and X4. So you need to put the full name for X1, X2, X3, X4. Right. So adjusted R square is equal to 0.584. So it means that there are 58.4% of the total variation can be explained by X1, X2, X4. Right. So adjusted R square is preferred for multiple linear regression. Yeah, we always prefer adjusted R square compared to R square, because when we input more variable into the model, R square, adjusted R square will not increase drastically compared to R square. Dia akan naik lagi banyak. Okay. That's one line. No question? Right. So example number 8, I think you can do by yourself. Example number 8, we have two slide. Right, sebatang muat. Example number 8. Ada 3 slide. Sebatang muat. Example number 10. Number 9. This is number 9, right? Where's number 9? Number 9 tu I think you can do by yourself. Number 10. Okay. So you can do until example number 11 by yourself. Any question before we go further? All right. So this is the equation that you need to remember. R square is equal to SSR divided by SST. And we can use another one is 1 minus SSE divided by SST. Right? And for the multiple linear regression, we can use summation of actual minus predicted. This is also equal to summation of y minus y hat square. This is sum of square error. This is summation of y minus y bar. And this is summation of y hat minus y bar square. So you know that a predicted value is, you get the predicted value based on the regression equation. Right? Okay. Boleh? Very good. So now let's look at example number 12. So this is, remember, this is a linear on our table for multiple linear regression. So now let's look at example number 12. So a set of experimental runs was made to determine a way of predicting cooking time. Cooking time is Y. This is same example as previous, right? And what are oven, width, and flue temperature. So based on our last example, we know that y equal to what? 0.58, right? This is cooking time and example number berapa tadi? Example number 4, right? Sama kan? Right, so we got 0.558 or 50? This one. So are you sure this one 0.50? Sekejap ya, I reconfirm. So this is oops. Y, x1, x2, 6.4. So tengok, you already know how to find multiple linear regression using Excel, right? Yes. So use Microsoft Excel to compare or confirm your result in assignment. The last one is 1.15, 2.4. Right. So by using Excel, you dah key in data. So go to data tab, find data analysis, right? And then find regression, input Y, X you input from X1, X2, and then put label because our first value is label, output range, put here, right? So this is 0.56, right? I think salah kira tadi kan? 56, not 50. Okay. So let me put the value. So this is Y equal to 0.567 plus 2.71. So this is 567 lah. 57 27 x1 plus 2.05 x2. Right. Okay. So now this one I think we already calculate just based on example number 4. So we want to compute sum of square error. Sum of square error is equal to summation of y minus y predicted square. Okay. So how to find y minus y predicted summation? So use calculator. Click on spreadsheet. So or else you need to calculate manually lah. Right. Use spreadsheet. Ada semua ada kan? Oh, you don't have? So do you get this page? Spreadsheet dapat? Belakang? Right. So you key in data 6.4, in everything lah. You masukkan data dulu. You sepatutnya dah habis lah. I belum. So don't worry, this kind of calculation will not be in your final exam. Right, but in your assignment, you need to do this lah kan? Kejap. I just remember. Tak apalah. Kita skip this one. Right? Assignment you use Excel lah. Right. So masuk sini. You need to calculate this table kan. But it require you to calculate manually. Right. So you need to calculate manually kan. So summation of SSE is summation of Y minus Y predicted. Right. So this one you input into the Excel. So this one should be, we need to find Y predicted first. Y hat. Y hat should be 0.57 plus 2.71 multiply with X1. Oh, sorry. I lupa nak letak reference. Right. So multiply with X1 plus 2.05 multiply with X2. So you get Y hat. So this is SSE. SSE Y minus, oops, equal. This is equal Y minus Y hat square. Right. So the summation is 2.8. Nampak tak? Sama kan? Right. So you can use the formula that I give to you. SST Y minus Y bar. So SST equal Y equal to Y minus I think I calculate mean dulu, okay? It's not mean, it should be average kan? Kejap, betul ke formula tu? Macam tak betul je. So the total should be 10956, right? Okay. So from there you got construct a number table and so on for assignment. Okay. So then we finish chapter 11, chapter 10. So next week on Thursday, we look at chapter 11. Hopefully we can finish on that day. On Friday, we will discuss some past equation. Don't have. Okay. Any questions so far? Ada soalan?